Okay, we welcome you to the second edition of our online practical BCH 212. And let me just quickly remind you what we did last week. We were able to qualitatively qualitatively look at whether there was some amino acids present in given samples or in proteins, and then we're able to do that successfully. So today we are moving on to see how we can estimate protein from given samples. In biochemistry, you can be given any sample to analyze and then to estimate or even to determine whether what you're interested is in it. Like you can be asked to check for protein in a given sample. And that is exactly what we are trying to do. So if you are given a biological sample, for example, and you want to estimate protein in it, you first need to crush the sample so that you can be able to increase the surface area of your sample. And when you crush, you can use using an homogenizer, or you can use mortar and pestle to increase the surface area. And when you have done that, then you can use some chemicals to be able to precipitate the protein out. In your manual, you see ethanol. You see you can use 80% ethanol water, but you can also use some other thing. You can use TCA, 10% TCA. You can use 0.33 molar HCl. You can also use sodium tungstate, or you can also use ammonium sulfate to precipitate your protein. When you have centrifuge it, you'll be left with your protein sample, and then you can then analyze or even estimate the amount of proteins that are present. So today we want to see how we can estimate the amount of amino acid, or the concentration of amino acid present in a given sample. So let's assume that we're analyzing for an amino acid. And what we prepared something, we prepared leucine. This is leucine, 5 milligram per mil. We have prepared it, you can see it. So from this, we can create what we call a serial dilution. We can create a serial dilution. So in biochemistry, we try to work from the known to the unknown. So we try to see how we can start from what we know and then get what we don't know. So we start from a given concentration of a sample, or let me say a given concentration of what we know, an amino acid in this instance. We know the concentration, 5 milligram per mil, and then we can do what we call a serial dilution. And when we have done the serial dilution, we can use that to estimate for an unknown. I hope you are getting that. So to create a serial dilution, we can take some amounts from the known. So we're going to take 0.2. We have some test tubes. We take 0.2, 0.4, 0.6, 0.8, and 1 mil of the known sample. 0.2, 0.4, 0.6, 0.8, and 1 mil of the known sample. And then we can then try to find out what is the concentration present in each tube for the 0.2, for the one that we take 0.2, for the one that we take 0.4, 0.6, 0.8, then the one. What will be the concentration of the amino acid? In this case, leucine, that will be present in each tube. Now, when you have taken the different volumes, you make them up to 1 mil with water. So, if I take 0.2 mil of my leucine in my first tube, I will label the first tube 0.2. I will label the first tube 0.2. And then the second tube is 0.2. Then the second tube, I label is 0.4. So I'm going to need 0.8 mils of water to make it up to 1 mil. That is the first tube. I will need 0.8 mils of water to make my 0.2 mil of the amino acid to make it up to 1 mil. Then 0.4 mil, I'm going to need 0.6 mil of water. For the one that is 0.6, I will need 0.4 mil of water. For the one that is 0.8, I will need 0.2 mils of water. And then we also have 1 mil of the sample. So we can then try to calculate the concentrations that will be present in each of the tubes. And then when we have done that, we can then create a graph. In biochemistry, there is a formula that we use which makes us to understand that absorbance, the relation between absorbance and concentration is linear, and that is the Beer-Lambert's law. So when we have gotten the concentration for each of the tubes, then we can try to get the absorbance. There is a machine that we make use of in getting the absorbance of samples, and the name of the machine is the spectrophotometer. This is the spectrophotometer. You can see it. It measures readings of